Hello everyone, my name is Yusuf Yıldız and I'm working as a solutions architect in LINBIT. In this video, I would like to give you a short overview and a demo about our latest invention, WinDRBD. So WinDRBD is a block replication technology that works in Windows. In order to achieve that, we used as LINBIT the original DRBD codes, and we added multiple patches into it so it can work with the Windows kernel. And now we are able to do block replication in Windows machines, which is really easy. In here you see the architecture of the WinDRBD. So in the core of the module, it is the RBD, but we added multiple patches into that so we can actually use it in the Windows level. The rest of them are actually stays the same, so like the DRBD ADM commands, DRBD setup commands, even the configuration files, everything stays the same. So if you are familiar using DRBD, you will get used to it used in Windows environment also. So after the explanation, let me lead you to the demo that I prepared today. In order to install and use the DRBD, first we have to go to linbit.com and then the download section. In the download section, you will see below that there is a Windows driver here. You can install any of them. They are all stable after one release. Let's go with the 102 right now. And let's do the same for the second machine, because we will have two machines to achieve high availability in Windows or in Linux, right? linbit.com, downloads, and this guy here. Once we download the package, we have to let's move it to the desktop so we know which machine that we are running. I put a couple of notes here so you can understand. This is the WinDRBD node 1 and this is the WinDRBD node 2. So the first step is to install the WinDRBD in the machines. To do that, you just need to run this executable as an administrator. And this says we found a DRBD version which is a little bit older than this, but you're going to install a new one. And I say yes, next, and install. And this is actually it. Now we install the DRBD into the machine as a kernel driver. Let's do the same for here too. Now the installation is completed. To test if everything is working fine, just open a command prompt and type DRBD ADM status. If you see this message, no currently configured DRBD found, looks like everything is working fine. Let's also check here. This also shows us that no currently configured DRBD found. So this DRBD ADM command is actually from the original DRBD utils. And there are many DRBD commands you can use, just like DRBD ADM, like DRBD setup. If you want to use it, I mean, these are the things that we use for modifying the DRBD connections and the resources. And DRBD ADM is, oops, sorry, I just typed DRBD ADM. Okay, this is most likely to adjust adjust and a little bit change the existing resources and stuff. And before we start, I want to show you one thing about DRBD and how it works, the logic. So I have prepared two SVG files for you guys here. So let's say this is our setup here. All right, so we have one node on the left, one node on the right, and the left one has a physical disk as well as the right one. And what happens is, let's say you have an application in the node 1 working on top of a file system. Most likely for Windows, it will be an NTFS or ReFS. And then the file application writes something to the file system. And then the file system actually writes the data to the physical disk. But the WinDRBD or DRBD in Linux actually gets between the file system and the physical disk itself. So DRBD actually consumes the physical disks, and then it shows itself to the operating system as a disk, and then you can create a file system on top of DRBD. So on the left hand side, you see the node 1 is active, and the node 2 is passive, and the secondary in this case. If something happens on the node 1, or even if you want to move to the node 2, you can see through the arrows that the replication link is going through primary to the secondary. And the secondary DRBD also working through the next, by the way, the replication is happening through the next. The secondary DRBD is taking the changes, receiving the changes from the primary, and writes it to the local device of the node 2. If something happens on node 1, or if you want to move to node 2, what happens is you basically stop the application, unmount the file system, and then go into the node 1, mount the file system, and then start the application. This is the manual way. And right now we are working on a cluster mechanism on Windows. We already have it on Linux in many ways, like DRBD Reactor, Pacemaker, and so on. We already have it on Linux for many, many years now. That's our expertise is. And right now, we just ported the DRBD into Windows World. And now we are working on the clustering mechanism. So you don't have to worry about like switching between two nodes manually. But right now, everything is manual for you guys. And when you do the switchover to node 2, what happens is the primary and the secondary change sides, and the application is now running on the node 2. The file system as well as the application is running on node 2. Now the node 2 is primary and the secondary is receiving changes from the node 2, the primary DRBD. All right, so let's start configuring our system, right? So I added 1 gig of disk into these machines, both node 1 and node 2 here. These are the VMs, by the way. I'm running on the VMs for this demo. So in real world, if you're using VMs, that's gonna be that's not gonna be an issue. But if you're working on a bare metal environment, you will also have the physical disk and drives. You cannot add it while on the go, but maybe you can add it before, then you modify it. So there is no difference. Okay, let's check our disks, right? Let's go into the disk management on both sides. All right, so it founded the disk immediately. It will be a GPT. And let's create a new simple volume out of this. Let's assign a letter. I would like to use the E drive. This is important. So there's two ways of installing and using DRBD. The first one is the disk itself. It has already has a data in it. And the second one is it's a blank disk. So in this case, the disk is blank. So we will use the blank disk, but do not format that volume, because what we will have is another disk on top of disk one, and then we will create our file system and the partition formation on top of that. So we will just use the do not format this volume settings here, and then next, and then finish. So but now I'm guessing you're thinking, what if there is a data inside of the disk that I want to replicate? It's a good question, and it's already covered by DRBD. Only thing you need to do is, which I will show you in the configuration file part. Only thing you need to do is you have to put the metadata into another disk, and then you can replicate a drive that is already containing some data of yours. I will explain a little bit later on. Let's do the same one here, the GPT, and then new simple volume, next, and let's assign E, because I like the E. My wife's name starts with E, and finish. All right, now we have prepared everything for now, but now we have to move on to the second phase of creating the DRBD pair. Now we can close these things, and we have to open a certain directory on both machines, which is this one. So in local disk C, there is a WinDRBD folder, and then there is etc folder, and then there is a drbd.d folder. In this folder, we are putting our resource files so you can edit and set up your DRBD pairs. So I already created a resource file for this demo, and then I will explain it to you. Let me show you this. All right. So this is a simple resource file. DRBD has many options that you can use. Many differentiates, many different things that you can change and you can tune into your setup. But right now I'm using a blank simple one that so we can do the test. And let me explain to you line by line what happened here, what happens in here. So we need to give it a name. It's a WinDRBD test. I choose this name. We have to set a protocol. I choose the C protocol right now. C means synchronous. If I do it A, that means asynchronous. So what means is, when you do a replication between two nodes that is really close to each other, you can use the synchronous mode, and that means that you have a good bandwidth and the low latency between two nodes. But if you are trying to replicate between two different data centers, or a long line, or problematic bandwidth issues and things like that, then you might want to go with the A1, the asynchronous version. Because in synchronous mode, let me open my image again here. In synchronous mode, when primary receives an IO request, IO write request from an application or a file system, in synchronous mode, it writes to the local device, sends the IO to the secondary, and then waits for a confirmation from the secondary. If secondary doesn't return any confirmation, the primary waits until it goes back to the file system, say, I write it what you requested for. But in asynchronous mode, DRBD, the primary one, writes it to the local disk, sends the data to the secondary DRBD, but doesn't wait for a reply from the secondary. So you might think, why I should use asynchronous mode? Because when the networking between node 1 and node 2 is problematic, and if you're using synchronous mode, that will give you a little bit trouble about your performance. Because if the primary is not able to get a confirmation from secondary all the time, that means your IO will hang, and that will give you headaches. So in long distance replications, you might want to choose the asynchronous mode. If you don't have such problems between your data centers, that's also possible. Maybe you have a dark fiber or something. You can use synchronous mode, or maybe between two nodes in the same data center, whatever. I think you got the idea about this. So I defined the nodes here, like sandbox 1, sandbox 2, I gave the IPs of the replication link. I can differentiate it. I don't have to use the same IP with the machine, so I can create another interface just for the DRBD replication. So I used the port of 7601. In here, for each resource, you have to use a different port. For example, this is the test.res file. If I would add another one, then I need to use a different port number here and also different device miner here. That's the thing. So I gave the node IDs 1 and 2, the volume numbers 1, and here also 1, and the disk. So this is important. So as you can see here, I identify the disk part here, which disk that the DRBD will consume. So I'm using the letters here, but I can also use the GUIDs of the disk, because letters can change from time to time. So if I don't want to do any misconfiguration, I can also use the GUIDs, but letter is fine. I mean, if you know what you're doing. And the meta disk part, I'm using the internal right now because the disk is blank and it's not used. If there is a data inside of the disk that I want to replicate, then I have to use the external meta disk part, and then I have to define another section that is telling me where to put meta disk. And the device miner is the configuration attribute in DRBD. I'm using 5 right now just for this test. So this is my configuration file, simple as it is. I mean, I just need to put 2 nodes here, 1 and 2, and it should be just fine. Hopefully, let's see. I need to move my resource file into this directory. Let me do it for you guys. Okay, DRBD2. All right. So now let's start with the DRBD ADM up WinDRBD test command. So it will complain about that there will be no metadata found. So we have to create the metadata first, because each DRBD resource has a metadata inside of it. So let's create one. To do that, you have to write DRBD ADM create -md and the resource name WinDRBD test. And you have to do the same on the second machine, DRBD ADM. Oh, I'm sorry, DRBD ADM create md WinDRBD test. Now that we created our metadata, let's up these resources. DRBD ADM up WinDRBD test. I'm sorry, there's a typo again. And let's do the same here. DRBD ADM up WinDRBD. Now, for next step, we need to start the synchronization between these two DRBD resources. In order to do that, we have to run this simple command, what we called DRBD ADM new current UID -- clear bitmap, and then the resource name WinDRBD test, and then the volume number that we used in our resource file. Once you've done this, just check with the DRBD ADM status. You will see that both disks are up to date and running synchronization. After this point, you can stop using the command prompt and then move into the management again. Just go into disk management. You will see that our disk is here, healthy and not used, not consumed. Now we have to do a primary DRBD ADM primary WinDRBD test. After I done this, you immediately see that another disk just showed up here. So we have to make it online, initialize it with GPT is fine, and then let's create a new simple volume, and this time let's use the formatting option and finish. Let's check our PC here, and you will see the E drive is not used, but there is another drive on top of E which is called D drive. Let's put some of the images here. Now we put it, and let's switch between node 1 and node 2. In order to do that, first we need to obviously make this offline, then change this to secondary. So the first node is now secondary. Let's change this to primary. And now, only thing you need to do is to, again, open the disk management here. And you will see that the disk is here and the data itself is present. So this was the short demo of WinDRBD. As you can see here, it's really easy to move on and create a block replication between two nodes. You can extend this this example into like replicating databases, replicating file systems on top of the DRBD devices, or even you can create backup options like this. The good part of WinDRBD is it is taking all of the existing features from DRBD except one or two, and it ports into the Windows platform, and you can use it without any hesitations because it's now in the stable release. If you need any support to installing WinDRBD, please write a comment into this video, or you can find us in our Slack channel. You can find it in our website for the link, and we are glad to help you in your setups anytime. Thank you for listening. Thank you for watching this video, and have an interest in WinDRBD. Have a good day and stay safe.